9. Today we'll be discussing on lab 3 for RF oscillator simulation. So our objectives for this lab is to simulate RF oscillator behavior, for example Colpitch or LC oscillator. Then we will observe waveform generation and frequency stability. And we will link an oscillator with the communication circuit. So for the first task, you need to implement an LC oscillator using MATLAB equations or similarly. So we will use MATLAB equation. So here is the code for the first task. So this will be the parameters for the induction in Henrys, and this will be capacitance in farads. And we'll be using this formula for the resonant frequency 1 over 2 pi square root L times by capacitance. And for the time, we use 1 over F, and this is the given sample frequency to simulate time and the time step with the time factor. We have the initial condition of V initial of 1 and initial inductor of 0. So this is how we locate V and I, and we set the initial values here. So this is time domain simulation using Euler method. And here is to plot the result for LC capacitor voltage and LC oscillator inductor current. So when we run this, we will get the capacitor voltage and the inductor current. As you can see, it's 1, 0, and -1. And then initially 0, and then it gradually goes increase. Okay, so let's move on to the next task. Okay, so for the next task, we have to vary the component values of L and C and observe output frequency. So, okay, so over here we set the parameters for the sweep ranges. For this is in henries and this is in farads. This is for three times by 3 rows and column with different induction and different capacitance. And then we have a sampling frequency here. Is the time step formula. We have an time of 2 millisecond. The same initial condition as the first task. Here is the code for the looping for the LC combinations. And then over here we have the plotting for for each for each of this category. So when we run this, we'll have 9 results. This is like based on this, and it's times by 3. So these all different frequency with the designated capacitance as their column, and per row is their frequency. Let's move on to the next one. So for task 3, we are going to add noise and observe a frequency jitter for an example value. So these are the parameters for task 3. This is the inductance value that we have set, and this is the capacitance. These are the same as the previous task. The initial condition is also the same. We have located noise strength of 0.6. And then this for no noise, and this is for with noise. We set the initial values for the clean and the noisy one. But this V naught and I naught is based here. And we have our Euler integration for the clean and the noisy. And here is the coding for all the plotting. Okay. So this is the graph. So as you can see here, the clean one is the blue colored one, and the noisy one is the red one. This is for the time domain for clean versus noisy LC oscillator. Then we have the frequency domain for the clean and noisy oscillator. You can see it has a higher peak for noisy and a shorter peak for the clean. So let's move on to the last task. So compare simulation output with theoretical frequency, and it has been given a formula of F equals to 1 over 2 pi LC, square root of LC. So let's see the comparison in lab 3, 4 here. Okay, so we have our constants. It is all based on the previous task, and the noise is still the same. This is the set value for each L and C. As you can see, they are also the same as the previous one. Then this is to locate the result table in like which column and which is the rows. These are to loop the LC value, so it does each of these value in this formula, and it will rearrange in this code. Then this will simulate the clean, and this will simulate the noisy, and it will all be filled in the result table. So this is to display the result. So let's see the result. So this is the inductor and the capacitance that we have set over here, which is this one. And this is the frequency theory. It is frequency for the clean, it is for the noisy, and then we have the error clean formula for clean and noisy. Same, clean, noisy. Okay, so that's it for us. Thank you.